Now, in this topic, we are going to discuss geometrical isomerism in aldoxime and ketoxime. They are having this particular functional group, C double bond N, and nitrogen is attached to the OH. Okay, now this compound having C double bond N means there is a double bond, and here there is a different arrangement of atoms or a group around the C double bond N. म्हणजे या कार्बन डबल बॉन्ड नायट्रोजन भोवती ऍटम किंवा ग्रुपची रचना वेगळी असू शकते, and therefore this compound shows geometrical isomerism. Geometrical isomerism is not only observed in compound having C double bond C. फक्त कार्बन डबल बॉन्ड कार्बन आहे अशा कंपाऊंड मध्ये geometrical isomerism आढळतो असं नाहीये. It may be observed in those compound which having C double bond N. For example, oxime. First, we will see what is actually mean by oxime. Consider example. Okay, this is RCHO. RCHO. This is general presentation of aldehyde. Suppose this aldehyde is treated with hydroxylamine. What happens when this aldehyde is treated with hydroxylamine? These two molecules undergo condensation. Here that oxygen and these two hydrogen atom form H2O as a byproduct. Okay, and there is a formation of double bond between carbon, this carbon, and nitrogen. This compound is called oxime actually. This compound is prepared by using aldehyde. Hence, it is called as aldoxime. Generally, oximes which are prepared by using aldehyde, they are called aldoxime. Now let us see second, what is meant by ketoxime. Okay, simply we can say that ketoxime means they have been prepared by using ketone. Okay, this is R, C double bond O, R. Okay, this is ketone. When this ketone is created with hydroxylamine, here also that two molecules undergo condensation, that oxygen and two hydrogen form H2O. Then there is the formation of double bond between carbon and nitrogen. Okay, this is double bond between carbon and nitrogen, and we get the oxime, and that oxime is called ketoxime. Suppose oxime is prepared by using aldehyde, then it is called aldoxime. Suppose it is prepared by using ketone, then it is called ketoxime. In aldoxime, that double bonded carbon should be attached to the at least one hydrogen, then it is aldoxime. While in ketoxime, that double bonded carbon is attached from both sides by carbon. Okay, this is just about the aldoxime and ketoxime. Now we will see why they show geometrical isomerism. Means we will see the cause of geometrical isomerism. How that compound, that means the compound which having C double bond N, that is oxime. And we will see why this shows geometrical isomerism. Let us see first about the structural arrangement of that carbon double bond nitrogen. We will see structural arrangement. Actually, how that C double bond N is formed. हा C double bond N कसा तयार होतो हे पहिल्यांदा आपण बघूया. There is a double bond between carbon and nitrogen, and out of that two bond, one is a sigma and one is a pi bond. Okay, we will see about that carbon double bond nitrogen first. Suppose this is a carbon atom and this one is the nitrogen. Now, what is the hybridization of that carbon and nitrogen? Here, both carbon as well as nitrogen, they having sp2 hybridization. The hybridization of both carbon and nitrogen is a sp2. म्हणजे one s orbital and a 2p orbital, they mix up and recast. Means there are 3 sp2 hybrid orbital, and here sp2 hybrid orbital of carbon overlaps axially with the sp2 hybrid orbital of nitrogen to form sigma bond. Okay, this is the sigma bond between carbon and nitrogen. Suppose that carbon again having two sigma bond, and that sigma bonds are formed due to axial overlapping. Okay, nitrogen also form one sigma bond with OH. Nitrogen also having one more hybrid orbital, and suppose this is the hybrid orbital and this is nothing but the sp2 hybrid orbital, and this sp2 hybrid orbital having lone pair of electron. म्हणजे नायट्रोजन वर जी lone pair of electron आहे, this lone pair of electron is present in that third sp2 hybrid orbital. This is just about the sigma bond formation. Now carbon as well as nitrogen also having unhybridized 2pz orbital. Suppose this is unhybridized orbital of carbon, then Nitrogen also having unhybridized orbital. Now that unhybridized orbital of carbon and nitrogen, they overlaps laterally with each other, and there is the formation of pi bond, and this is the pi bond which is formed between carbon and nitrogen, while this one is the sigma bond which is formed between carbon and nitrogen. And thus in between carbon and nitrogen there is a one sigma bond and one pi bond. How the sigma bond is formed? Due to axial overlapping. How the pi bond is formed? Due to sidewise overlapping, due to lateral overlapping. There is a formation of pi bond, and thus in between carbon and nitrogen there is a one sigma and one pi bond. Okay. Due to this situation, rotation about carbon double bond nitrogen is not possible, and therefore the positions of atoms or groups around the carbon and nitrogen are remains fixed. म्हणजे कार्बन आणि नायट्रोजनच्या भोवती रोटेशन पॉसिबल नाहीये, आणि दिस इज कॉल्ड रिस्ट्रिक्टेड रोटेशन. मग रोटेशन होत नसेल तर त्यामुळे काय होतं, कार्बन आणि नायट्रोजनच्या भोवती असणारे जे ऍटम्स किंवा ग्रुप आहेत त्यांच्या पोझिशन फिक्स राहतात. म्हणजे सपोज या ठिकाणी जर एखादा मिथिल ग्रुप असेल आणि या बाजूला OH असेल तर या ठिकाणी यांच्या पोझिशन फिक्स राहतात, त्या चेंज होत नाहीये. किंवा जर त्या ठिकाणी मिथिल आणि OH अपोजिट साइडला असतील, दे रिमेन्स ऍट द अपोजिट साइड. सपोज दे आर प्रेझेंट ऍट द सेम साइड, दे रिमेन्स ऍट द सेम साइड, अँड देअरफॉर वी आर हॅव्हिंग, म्हणून त्या ठिकाणी जॉमेट्रिकल आयसोमेरिझम आपल्याला ऑब्झर्व होतो. देअरफॉर जॉमेट्रिकल आयसोमेरिझम इज ऑब्झर्वड. Okay, in between carbon and nitrogen, there is a double bond. One is a sigma and other is the pi bond. We have studied how that sigma bond is formed. We have studied how that pi bond is formed. हे आता आपण बघितलं, आणि त्यामुळे काय होतं, due to this situation, there is a restricted rotation about carbon double bond nitrogen, and hence the positions of atoms or group around the C double bond and are remains fixed, and therefore geometrical isomerism is observed in oxide. This is the cause of geometrical isomerism. Okay, this is the just introduction why geometrical isomerism is observed. Now let us see geometrical isomerism in oxide. आपण बघूया या aldoxime मध्ये आणि ketoxime मध्ये how the geometrical isomerism is observed. We can simply say that geometrical isomerism in oxide is observed due to different arrangement of atoms or group around the C double bond. And let us see a very simple example. Now, in the case of that geometrical isomerism, we are using syn and anti instead of cis and trans. आपण अल्किन मध्ये काय वापरत होतो, cis and trans, but here we are using syn and anti. तिथं मात्र आयसोमरला आपण नवीन शब्द वापरतोय. Instead of cis we are using syn and anti. Okay, now let us see example. I will explain. This is example of aldoxime. Why it is aldoxime? Because that double bonded carbon, this double bonded carbon having one hydrogen means it is aldoxime. हा जर डबल बॉन्डेड कार्बन दोन कार्बनला, then it is called ketoxime. आपण त्याला ketoxime म्हटलं असतो, but here there is one hydrogen, hence it is aldoxime. Now let us see how that aldoxime is having geometrical isomerism. Actually that compound is called benzaldoxime. या कंपाऊंडचं नाव आहे benzaldoxime because it is prepared by using benzaldehyde. हा benzaldehyde पासून तयार होतोय, and hence it is called as benzaldoxime. Let us see how it shows the geometrical isomerism. Okay, this is the first possible isomer. Now first double bonded carbon having one phenyl group and one hydrogen, then there is one nitrogen, and this nitrogen having only one OH group. Okay, this is the first possible isomer. Here I have shown hydrogen and OH at the same side of double bond, and this is the second isomer. What is the difference? Here hydrogen and OH, they are present at the opposite side, means that two isomer, both are benzaldoxime. They having same molecular formula, they having same structural formula, but what is the basic difference? In first case, that hydrogen and OH, they are present at the same side, while in second case that hydrogen and OH, they are present at the opposite side. Okay, means here arrangement of atoms or group around the double bond is different. Here that first isomer, in which hydrogen and OH are present at the same side of double bond. It is called syn isomer. While in another case that H and OH they are present at the opposite side, then it is called anti-isomer. It is called anti-isomer, and thus H and OH, if they are present at the same side, then it is called syn isomer. And if that hydrogen and OH are present at the opposite side, then it is called anti-isomer. Now let us see one more example. We will see example of ketoxime. We will see example of ketoxime C6H5. This is one group. Then carbon. This carbon do not having any hydrogen, means it is ketoxime. In that ketoxime, always one group is considered as a reference group, and position of OH and reference group. On that basis, we can use the prefix syn and anti. म्हणजे OH ग्रुप आणि रेफरन्स ग्रुपची पोझिशन काय आहे यावरून आपण सिन किंवा अँटी हे प्रिफिक्स या ठिकाणी वापरतोय. लेट अस सी हाऊ दॅट कंपाउंड, हाऊ दॅट कीटॉक्साइम शोज जॉमेट्रिकल आइसोमेरिझम. ओके, दिस इज द फर्स्ट पॉसिबल आइसोमर. Here methyl group and OH they are shown at the same side. In second case, again same compound is there. Here OH and methyl group they are shown at the opposite side. How they are named up? याला आपण isomers ला कसं नाव देणार? Suppose we are choosing this methyl group as a reference. त्याला पहिल्यांदा आपण methyl group ला reference consider करूया. मग methyl group आणि OH यांची पोझिशन कशी आहे? They are present at the same side. Hence we can say syn methyl. We are using syn methyl. Then word phenyl. मग दुसरा ग्रुप कोणता आहे? तर फिनिल ग्रुप आहे. Therefore phenyl. आणि पुढे शब्द आपण लिहितोय कीटॉक्साइम. पण प्रिफिक्स मी कोणाला यूज केला? सिन. कोणाला यूज केला? मिथिल साठी. बिकॉज मिथिल अँड OH ग्रुप दे आर प्रेझेंट ऍट द सेम साइड. Therefore it is called syn methyl phenyl ketoxime. Suppose we are choosing phenyl group as a reference. OH group and phenyl they are present at the opposite side. मग आपण काय म्हणूया? अँटीफिनिल. अँटीफिनिल. आणि मग सेकंड ग्रुप कोणता आहे? मिथिल कीटॉक्साइम. इन द सेकंड केस सपोज फिनिल वी हैव चूजन phenyl group as a reference, then phenyl group and OH are present at the opposite side. Hence we are using prefix anti. फिनिल ग्रुपच्या अगोदर प्रिफिक्स वापरला अँटी, म्हणून त्याला आपण नाव देतोय अँटीफिनिल मिथिल कीटॉक्साइम. ओके, दिस इज द सिस्टम फॉर द नॉमेनक्लेचर. नाउ लेट अस सी नेक्स्ट वन. या ठिकाणी मी चूज करतो आहे पुन्हा एकदा पहिल्यांदा मिथिल ग्रुप हा आपण रेफरन्स चूज करूया. मग OH आणि मिथिल ग्रुप दे आर प्रेझेंट ऍट द अपोजिट साइड, आणि म्हणून या ठिकाणी मी काय म्हणतोय? अँटी मिथिल. म्हणजे दोन्ही ग्रुपची नावं लिहितोय मिथिल फिनिल कीटॉक्साइम, पण आपण प्रिफिक्स अँटी कोणाला यूज केला? For the methyl, because methyl group and OH they are present at the opposite. किंवा दुसरा आणखीन काय पद्धत नाव देऊ शकतो आपण? सिन फिनिल मिथिल कीटॉक्साइम. सिन का म्हटलं तर फिनिल जर आपण रेफरन्स कन्सिडर केला तर फिनिल ग्रुप अँड OH they are present at the same side of double bond, and hence we are using prefix sin to the phenyl. म्हणून फिनिल ग्रुपच्या अगोदर सिन हा प्रिफिक्स आपण वापरतोय. Then write the word methyl and finally the word ketoxime. Okay, sin phenyl methyl ketoxime. Okay, this is just about the introduction of the geometrical isomerism. How that aldoxime and ketoxime they show geometrical isomerism.